Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today's lesson is about problem solving. I'm going to teach you how to solve this tricky question where most of the students are having problem with. Today we are going to focus on this year's question, May-June 2017, 9709-42, question 3. Let's read this question together. A particle A moves in a straight line with constant speed 10 meters per second. 2 seconds later, after the A passes through a point O, which is the origin on the line, a particle B passes through the origin again, moving along the line in the same direction as A. The particle B has a speed of 16 meters per second at the origin with a constant deceleration of 2 meters per second square. Before start answering the question, let me jot down all the information. Here's the origin. This is the particle A. Given that the particle A moves in a straight line with a constant speed. What does it mean by constant speed? Constant speed means the initial speed is 10. The final speed is also 10. And hence, the acceleration should be equal to 0. And then, 2 seconds later after A passes through a point O on the line, the B passes through the point O. Same direction as the A. For the B, the initial speed is 16 meters per second with a deceleration of 2. Let's jot down this. For the particle B, same direction as the particle A, initial speed is 16. The acceleration is negative 2 since they mentioned the word deceleration. Alright? As for the time, have a look at here. The particle B moved 2 seconds after the particle A. Let's say I put the time for A as t, which means the time for the B should be t plus 2 or t minus 2. Here comes the problem. Most of the students will think that the particle that moved later will be t plus 2 instead of t minus 2. But this is wrong. The correct one should be t minus 2. This one. Why is that so? Let me explain here. If the particle A is t, particle B, according to the student's answer, is t plus 2. Let's say now I try to substitute t equals to 10 into it, which means the A, particle A has already moved for 10 seconds, whereas for the particle B has moved for 12 seconds, which means the particle B actually moved longer, 12 seconds here. But according to the question, the particle B only moved 2 seconds later, so it should move a shorter time. So instead of having t plus 2, the particle that moved later should be a t minus 2. Please take note here. For now, have a look at the part 1's question. Find the expressions in terms of t for the displacement from the origin of each particle t seconds after B passes through the origin. Look at the t here. The t is defined after B passes through the origin, which means for this question, we start to calculate the time after B start moving. So let's say this is my particle A, this is my particle B, the t goes to the particle B. Whereas the t plus 2 goes to the particle A. Still remember what I mentioned earlier here? You can put the t for the particle A, whereas t minus 2 for the particle B. But for now, according to the question, they want the t to go to the particle B, which means t plus 2 goes to the particle A. Let me jot down this information here. For the A should be t plus 2. For the B, it should be a t. Alright, so what information we are having here? We have U, A, and T. The question asks to find the expression in terms of T for both the particles. So for now, let's do for the particle A first. For the particle A, the formula that we are supposed to use to find the displacement is S equals to UT plus half AT squared. What you need to do now is just to sub in the information, where the U is 10, the T is T plus 2, plus half times the acceleration should be a 0, and the time is T plus 2 squared. And hence, the expression will be 10T plus 20. That's the expression for the particle A. As for the particle B, we should use the same formula. UT, the U is 16, the T remains T, plus half, the A is negative 2, and the T remains T squared. And the expression will be 16T minus T squared. Here are the two answers for the part 1. Now, let's have a look at the part 2. For part 2, you are asked to find the distance between the particles when the bee comes to rest. First of all, we've got to find out the time when the bee comes to rest. When bee comes to rest, it means that V equals to 0. So let's find out the time when the V equals to 0 for the particle B. Let me jot down the information for the particle B. The U should be equal to 16. A is negative 2. When it's at rest, B equals to 0. And we are supposed to find out the T now. Which formula we are supposed to use? We should use V equals to U plus AT. For now, you just need to sub in the values. And from here, we can get T equals to 8, which means the particle is at rest when T equals to 8. Then, now we can find out the distance between the two particles. The expression for the particle A that we found in part 1 is 10T plus 20. As for the particle B, it's 16T minus T squared. And for now, we just need to substitute the T equals to 8 into each of them. And hence, you will get 100 for the particle A. As for the particle B, you will get 64. Therefore, you can conclude that the distance between the two particles is 100 minus 64, which is the 36 meter. That's how we solve for the part 2. And the last part, part 3, is the tricky ones. Let's read the question. Find the minimum distance between the particles. How to find the minimum distance between the particles? Still remember what you have learned in the AS? When you are finding minimum area, when you are finding minimum volume, what you are supposed to do? Isn't it you are supposed to differentiate it and equate it to 0? So what we are supposed to do here is to find out the expression for the distance between the two particles, and hence differentiate the distance equals to 0. Come, let's try that. For part 3, the first step is to find the expression for the distance between the two particles. And I name this as S. How to find the expression? We just need to use the expression for the particle A minus the expression for the particle B that we have found in part 1, which is 10T plus 20 minus 16T minus T squared. and hence we will get t squared minus 6t plus 20. This is the expression to represent the distance between the two particles, which is s. So if we want this distance to be minimum distance, we just need to differentiate the distance and equate it to a 0. Alright? So after differentiate, you get 2t minus 6 and equals to 0. And hence, t equals to 3. Which means when t equals to 3, the distance between the two particles now is minimum. And for now, we need to find out the minimum distance between the two particles. How are we supposed to find out this distance? We just need to substitute the t equals to 3 into the distance expression here. Let's try to do this together. You need to substitute the 3, it becomes a 3 squared minus 6 times 3 plus 20. And therefore, the final answer is 11 meter, which is the minimum distance between the two particles. This is how we solve this tricky question. That's all for this video. Thank you.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.